Welcome to 28th lecture in the course on Industrial Engineering and Operations Research. We have been discussing many topics relevant to Industry 4.0. We talked about big data, we talked about machine learning. Today, I am going to talk about one key enabler of Industry 4.0, that is Internet of Things, IoT. What is Internet of Things? Just like we have internet, we can most of the time we have lot of document material available on the internet. It is in the form of, you can say, software, but here Internet of Things means in terms of the things, it can be even object. That means just like that various web pages are connected to each other, here many devices are connected to each other. One truck and another truck, both the trucks are going, but driver of and one truck knows that location of the another truck. They are connected by some network. That type of thing can be called Internet of Things. So Internet of Things refers to a network of physical devices, vehicles, appliances and other items embedded with sensors, software and network connectivity, allowing them to collect, exchange and analyze data. These devices communicate with each other and with other internet enabled devices without direct human interaction. You might have seen that sometimes 4 or 5 friends decide to go on the picnic and they may take 2 cars. Some people, maybe 2 persons sit in one car and 3 persons sit in another car, or it can be even bigger group. There may be 3-4 cars also. Then they decide that that I will be moving the first and you keep seeing that our car and follow us. There is a lot of coordination problem. Sometimes the driver sees that, he stops and he sees that whether the other car is coming or not. So if it is connected with electronic system or it is connected in the cloud, then the location and everything can be fully visible to one driver about the other cars. So this is an example of Internet of Things, how easy things can be that if we have devices connected. Similarly, that if there is some machine breaks down, immediately that information goes to maintenance section. In the maintenance section, there may be some alarm which gets activated and which will give the signal that this action has to be taken. So many things can be connected with each other. So devices can communicate. That means machine itself will tell to maintenance engineer that I have broken down, please come and repair me. So this is the thing. So IoT, but in a way IoT can be called as a part of mechatronics, because physical objects and electronics also. So mechatronics in fact was the term which was coined in 1971. Little bit I want to discuss about mechatronics also, because it is a you can say that it is the mother of IoT. So mechatronics means that you taking the help of mechanics, electronics, software control, digital control, CAD/CAM control circuits, all these things together. Term mechatronics was registered by an engineer named Tetsuro Mori of Yaskawa Electric Corporation in 1971, but in 1982 Yaskawa elected to abandon its right on the word. So now anybody can use the word mechatronics. Mechatronics is actually now in the education sector. We are teaching the mechatronics as a subject also, as a BTech program also, and in fact mechatronics has progressed a lot. Just for interest, I am just telling that microprocessor 4004 was introduced in 1971. It was using 2300 transistors and had a clock speed of 108 kilohertz. But I have taken this thing from the book of Gawankar. You can refer that book also. This is microprocessor architecture, programming and applications with 8085, which was very popular microprocessor, and we can see that how the growth has taken place. That earlier it was 4004 and which was having only 2000 the 300 transistors, but finally we got even Pentium 4, which is having 42 million transistors, and even clock speed, which was 108 kilohertz, has become 1.4 gigahertz. So these are the developments have taken place. Even we see that in 1946, ENIAC first general purpose computer was made, which was using lot of vacuum tubes, etc. But now the same type of thing can be obtained even in your mobile phone. So word mechatronics is the combination of words mechanical and electronics, and these two disciplines have major influence on the development of mechatronics. So we have, in fact, advent of mechatronics can be traced to the early 1950s also, because a prototype numerical control machine tool was demonstrated at a Massachusetts Institute of Technology, MIT in USA. In 1957, the first computer numerical control machine was developed at MIT. In 1961, the part programming language automatically programmed tooling was released for automatic machining of the components on CNC machines. So we see that basically in 1950 and 1960, lot of development took place about computer numerical control machines. In 1959, Planet Corporation introduced the first commercial robot based on limit switches and cam. In 1961, a Unimate robot was installed by Ford to service a die casting machine. In 1978, programmable universal machine for assembly, that is Puma robot, was introduced by Unimation. So Puma robot was also very popular. In 1979, Scala robot was developed in Japan. It is called selective compliance arm for robotic assembly. So like that, we see that in that decade, this was the decade of basically industry 3.0. So lot of development took place. In 1998, Honda introduced the P3 humanoid robot. In 1999, Sony introduced the artificial intelligence robot Dog. In 2000, Honda introduced advanced setup in innovative mobility, that means Asimo humanoid robot. In 2007, Tommy USA introduced iSobot humanoid robot, and this is the type of developments have been taking place. By 1990, mechatronics had established itself as an important field of engineering, and mechatronics journal was launched in the UK, which is available nowadays in Science Direct. Now, so mechatronics, there are many definitions, but we can say that mechatronics is the application of methodology, techniques and understanding of one or more disciplines to another discipline, and there can be several definitions of this one, but we can have define mechatronics is the synergetic combination of precision engineering, electronic control technology and systems thinking in the design of products and processes. So basically it is a synergetic, means mechanical and electrical etc. go together, and therefore IoT becomes a part of that type of mechatronic things. You have precision engineering there, you have electronic control also, you have system thinking also. Now example of mechatronic products are of course we can say CNC machines, computer numerical control machines, robots, material handling systems, flexible manufacturing systems, and in automobiles we have anti-lock mechanism of four-wheelers, electronic ignition system, engine control system. Nowadays lot of electronics has come in our automobiles also, and in aircraft etc. also, you know that control is being done by electronic systems. So therefore lot of application. If we talk about consumable products, now we have got cameras which use lot of electronics, they have microcontroller also. We have washing machines which can wash the clothes based on the fuzzy logic, and they have embedded microcontroller in that. Then we have toasters, then we have photocopiers. Now if we can, if the one washing machine can communicate with the other washing machine, our washing machine data can come in our mobile phone, and washing machine can also communicate to service provider, then it becomes IoT. In civil engineering, we have smart structures. There are also IoTs can be there. In fact, if the wall is breaking or if there is a crack in the wall, then wall itself will communicate and it will tell that I have broken and I need repair. So, this type of things are there. Now, some examples of mechatronics projects. Projects are very important part of mechatronics education. So, we are just telling, I am just giving that as a mechanical engineer we have tried to use that mechatronics since about 25 years ago, and these are some of old projects we did. We prepared that mechatronic field chair, we prepared that and we tested that which can run with joystick, and then we have got different type of motors, batteries. Even we made lifting mechanism, that how the with the hydraulic system the seat can be lifted, and we made the hydraulic system also there. Sometimes you have to use hydraulic systems, etc. Only thing that those days we did not put any communication devices there. Now with IoT we can put all those type of things. Automatic gear changing system for cars, we made that automatic gear changing system where gears can be automatically changed. So, we made use of a microprocessor, and these type of things have been done. We also made in the about in 2001 we made a low cost shop floor inspector robot. Those days it was about 50,000, maybe in today's term maybe about not more than maybe 2-3 lakhs rupees or maybe 4 lakh rupees. It can be prepared. In that it used to pick the objects and do the measurement and then decide whether the piece will be accepted or piece will be rejected. So, this was also done, and it used to work with the help of microprocessor. Later on it was operated by computer, okay, Pentium system also. So, this is just a schematic diagram of that robot, and we have done. Now, what happens that we can have many such examples about that. Now, I am just coming to that. In mechatronics, what do we study? Because mechatronics means mechanical and electronics, mechanical mechanism, etc. The students are already familiar, but main thing is that here we have to focus more on sensors and transducers, because IoT devices will have to employ some sensors and transducers. Without sensors, how can you get a feedback about surroundings and about other things? So, therefore, and many times people get confused about sensors and transducers. In fact, in many books also you may get different type of definitions. So, here I explain you in my opinion that transducer is something that which transforms one form of energy into other form of energy. Say, suppose you have taken displacement, displacement motion has been transformed into electrical signal. Similarly, you have pressure transducer in which pressure has been transformed into electrical signal. So, pressure is a mechanical energy and you got electrical energy. Now, transducer is basically that general thing, but transducer can be used as a sensor also, as an actuator also. That means it can sense something, it can be used for that purpose, or it can be used to do some work. That means I give some command and it takes action. So, that is called actuator. Like we can say hydraulic motor is an actuator, that means it takes some action. So, same mechanism can be used as a sensor also and transducer also. That if I put that strain gauge thing, okay, that strain gauge, if we use piezoelectric strain gauge and if I compress it and then I can get electrical signal. So, based on that principle I can measure the strain, because it will sense the displacement and it will convert corresponding charge, and finally we have charge amplifier, etc. Then we can find out that what is that type of this one strain. Otherwise it can also use sense load also. If I put some load and there is a piezoelectric crystal, so with the load it will get displaced, and that displacement we can sense, or that strain we can sense, and then we can get the idea about the loading. But it can also be used as an actuator. That means if I give a signal, then with a small displacement it can actually do some work, or that small displacement later on can be amplified. So sensor is just for sensing. So we have passive sensor, it has no power supply, and the energy for signal conditioning is drawn from the measurand, that means thing which is being measured. And active sensor means is a modulator, so it delivers more energy to next stage than it draws from the measurand. So we can have some example of sensors, that this is a limit switch. It is shown here that suppose some cylinder is moving and that cylinder touches here, then this lever will be activated. This is a small roller thing, and basically if something hits it, then naturally this lever gets actuated and then the switch is closed or opened. These are contact type of things. So mechanical limit switch, it consists of an actuator arm that operates a set of electrical contacts when displaced. Actuator is lever type and plunger type. We can have proximity sensors which can just measure from a distance without touching. It works on the induction principle or by the change of capacitance. So proximity sensors are non-contact sensors that work by electromagnetic induction. Inductive proximity sensors can detect ferrous or non-ferrous metallic object. Capacitive proximity sensors can detect non-metallic objects as well. And we have photoelectric sensors. We have seen such type of things, like sometimes you go to some railway station, etc., and there you see that automatic door is there which opens. So basically it senses your movement. One example of retroreflective photoelectric sensor is this, that suppose it is sending some type of that light, and then there is a reflector other side which reflects it back. So it knows that yes, I am receiving that light back. So there is nobody is there inside. But suppose you can have this one, some person has come in between, then the light will get obstructed, so it will not get back. So this signal will not come, that you are emitting but you are not receiving. So you will come to know that object has come. This is called retroreflective photoelectric sensor. Then we have many things like fluid flow switch, that which can measure the flow of the fluid. We can have reed switch, which is basically contactless input device, and contacts change over in the proximity of a magnet, this is also reed switch. Then potentiometer, just simply it measures that how much rotation has taken place. So there is a potentiometer, and this is going like this, and then you have this is a potentiometer. Finally you have LVDT. LVDT is well known to you, that linear variable differential transducer. This is also there. Resolver, which can tell, it is based on the magnetic principle, which can tell the position of a shaft. Now suppose you know you have got a resolver, and this resolver is basically has some type of winding on that, and there are two secondary windings here, that V1 and V2, they are at 90 degree to each other. So just like a transformer, it will introduce some voltage in V1 and V2, and depending on at what angle it is, that V1 and V2 will be different. So by that I can know, by measuring these voltages, I can know the position of the resolver. Similarly, we have optical encoder, in which suppose you have got a disc and light is coming from one side, there are many slots, and from the other slots it is going. So as it is rotating, then it is also telling you that how it is it goes that. So we can see that an optical encoder has some disc in which there are number of holes, and suppose one light passes through the hole and that is sensed. So, suppose one ray has passed through one hole, then second hole comes, then second ray, then you know that if the second light has come, that means that displacement has taken place equal to the distance between two holes. So, we have ultrasonic range sensors. Everybody knows that we can emit ultrasonic waves. The ultrasonic transmitter will be there, it will hit a target and then it will come back, that target will reflect that signal and it will be received by a receiver. By that we will be coming to know that how much time it has taken once I emitted the ultrasonic signal and then it came back, for how much time it has taken, and we know the velocity of the sound. So, by that we can know the distance, etc. And tachometers are the devices for measuring the velocity measurement. Basically, you can say tachometer is a type of a DC generator or an AC generator. So, generated voltage will be proportional to the RPM of the machine. By that we can know the RPM. So, we can measure the RPM and we can do that. Then smart sensors. Nowadays we talk about smart sensors. They compensate for non-ideal behavior of sensors. Now, no longer the sensor behavior should be linear only. Even if it is non-linear, it can be processed, and it also has generally provision for communication of processed data with the host system. So, these are many such type of things in that sensors and transducers. New developments are taking place. So, Internet of Things basically uses embedded sensors, etc. in the physical objects, and you can get this one. You can see that if you take RFID technology in the books, that is also a type of IoT device. That means wherever that book is there, then you will be getting the signal. And what are other enabling technologies of IoT? That we have Arduino, which is basically open source microcontroller board. It is ideal for prototyping, that Arduino. And then Raspberry Pi is also low cost full fledged Linux computer. It is good for edge computing. Edge computing means we want to do computing near the source only. That means suppose you have got you are driving a car, but there are many informations about the locations, etc. that can be processed centrally, but some decisions have to be taken immediately on the spot. Say suppose some accident is about to occur and you detect that signal something. If that signal is detected, that accident is about to occur, obstacle is detected, but that information if you send to cloud and cloud will process it and understand, yes, this signal shows that in front of the car there is a buffalo, then and then it will send the command for decision making. If you keep doing this type of thing, naturally it will take too much time. So, we cannot afford to have cloud computing. We have to do edge computing. That means at the basically edge of the things, you can say edge of the network. That means basically on the spot. That means we have to get the signal and immediately take the decision. So, this is Raspberry Pi can be used there. Then other type of things are also there. ESP8266 is also there. It is Wi-Fi enabled microcontroller. Then BeagleBone is there, STM32 is there. New developments are taking place and detailed information can be obtained from the internet nowadays. Other connectivity technologies are that how the Internet of Things will work. Suppose there is a sensor embedded in some device, maybe in my scooter it is embedded, but how the data will be transmitted, many things are there. Wi-Fi is suitable for short range high data rate communication. Bluetooth is used in wearables and short range low power applications. Then Zigbee is there, low power mesh networking protocols used in smart homes. LoRa is long range low power wireless communication for rural and industrial areas. So, we have LoRa. NB IoT is there, cellular technology is designed specifically for IoT. Ethernet is reliable wired connectivity, especially in industrial setups, that we use this is a wired connectivity, and nowadays we are talking 5G, like people are using 4G mobile, 5G mobile, high speed, low latency connectivity for massive IoT. So latency means there is not much delay since you got some input and then you give response. So if the time between input and response can be reduced, that means we have low latency. Then we have there are many companies, many things, many apps are there, like AWS IoT Core, Microsoft Azure IoT Hub, Google Cloud IoT, IBM Watson IoT, ThingSpeak. It is popular in academia and prototyping, and Blink mobile app platform for Arduino and similar boards. So like that, there are many apps which can be used for developing this thing. So in this lecture, it is not possible for us to discuss more about IoT and how they are working. This course being the course on industrial engineering and operations research, the main objective is to make you familiar about these technologies, and there are corresponding experts of these technologies. Suitably, one has to take the help of those experts and then make those type of devices. There are many software and operating systems that are used in Internet of Things, that free RTOS, real time operating system for embedded devices, then embed OS, lightweight operating system for IoT devices from ARM, Raspberry Pi OS. This is, as I already told, Raspberry hardware thing, microcontroller also you can take, but it is basically a type of small computer, and it is Linux based operating system is there. It is used in Raspberry Pi boards. Raspberry Pi boards can be purchased nowadays very cheap, within few thousands only people can purchase. Arduino IDE is popular environment for coding Arduino devices. Arduino boards can also be purchased very easily. Platform IO, cross platform IDE for embedded development, and Node RED, visual programming tool for wiring IoT systems. Then there are many things, because security is very important issue in IoT. Suppose you are driving a car which is giving information, it is like working like an IoT device. Car's location etc. is getting communicated to your head office. But if somebody hacks that program in between, then people can be misled. You are in Bhutan, but that that head office will understand that you are in Cherrapunji. So these type of things are there. So you have to have security technologies. So there are many type of security technologies. TLS, SSL, secure data transfer protocols is there. MQTT with TLS, lightweight messaging protocol with encryption, device authentication tools such as TPM chips or digital certificates. Then firmware over the air, FOTA, that is secure firmware updates. These security technologies can also be used. So then naturally the data analytics and AI we have already discussed, but they are very much integral companion of IoT. We can use the data. If you get lot of data through devices, then they can be analyzed by means of data analytics, and artificial intelligence also can take proper decision. So for making sense of IoT data, because you are taking lot of IoT data, but you need data analytics and AI. So edge AI frameworks, EG means, for example, TensorFlow Lite, TinyML, TensorFlow Lite is also there. So then you can make, and cloud based analytics is there, that is AWS, Azure or GCP offer ML tools, and time series databases, InfluxDB and Prometheus. So these data analytics and AI tools are also there. They can be connected with IoT devices. So this is how that IoT is actually becoming very popular these days. So only this much for today, and now in the next lecture we will tell some more interesting things concerning Industry 4.0.